Hi, everybody. My name is Julian Hora, and I'm the founder and CEO of Factorize, a company that focuses on building tools made for developers by developers. In our everyday work, JavaScript is at the core of what we are building on both the front end and the back end. We use Electron and React to build amazing hybrid web applications. And our entire cloud backend is also written in JavaScript and TypeScript. I originally come from game development and therefore C++. And moving on to web development, I had to modernize my approaches and visions on many aspects, including synchronous and asynchronous behavior. This talk will be dedicated to JavaScript beginners that just encountered or are about to encounter JavaScript async behavior. It is going through the very basic of the concepts and tackle different points such as HTTP request relations to asynchronous behavior, as well as promises and the use of async and await keywords. So let's get started. Usually, code is processed synchronously. It means that line 55 is run after line 54 and before line 56. I'm of course grossing it for the example here, but JavaScript as a single-threaded language does not escape that rule and can only run one statement at a time from the top to the bottom. If you are at line 54 on a function that requests data from somewhere else, and it takes time to come back with the expected return piece of data, you will have to wait for line 54 to have fully done its round trip and retrieved the value, no matter how long it takes before you can finally get to line 55. It is very important to understand that this is how code works traditionally. A program runs in order, or in other words, synchronously. This leads to an issue called blocking code. See, today, there are a lot of cases in which you will want to be able to perform other actions, execute other functions at the same time as a value is computed or received from somewhere else. Take the example of a request. You might need to fetch information from a database. You would then be confronted to the perfect case where you don't want the website to be frozen while waiting for the response to come back from your backend. And this is where asynchronous behavior kicks in. And asynchronous behavior is essential to web programming. Asynchronous functions allow developers to run a function without having to wait for the function to have received back its expected answer. The pattern we're going to find in these cases is the use of a callback function being passed to the asynchronous function. The asynchronous function would then run without blocking the process and will run the callback function once the request responses have been received. In a few words, JavaScript is capable of allowing asynchronous functions by taking these functions and running them in a different part of, say, the browser or the server, so that the main process scope stays unaffected by these functions' time to completion. There is a lot that could be explained about the event loop or other aspects of how JavaScript proceeds to allow asynchronous behavior. To avoid confusions and loads of information at once, let's keep it for another time. Now that we set the basics for synchronous and asynchronous meanings, let's get into actual use and samples. A lot of popular web API now use asynchronous code to run, particularly those that access or fetch any kind of external data, like fetching a file from another network, accessing a database and returning data from it, or accessing, for example, a video stream from a webcam, like you can see right now in this web application. Async callbacks are functions that are specified as arguments when calling a function which will start executing code in the background. When the background code finishes running, it calls the callback functions to let you know the work is done. or to let you know that something of interest actually has happened. Using callbacks is now becoming the almost old way of dealing with asynchronous JavaScript, overshadowed by a concept that we'll see in a few minutes, which are promises. Before I get into requests or HTTP requests, let me just bring up the point that asynchronous functions are present natively in your Node.js standard library. An example of an async callback is the second parameter of the addEventListener method. That's right, addEventListener is an asynchronous method. The first parameter is the type of event to be listened for. And the second parameter is a callback function that is invoked when the event is fired. When we pass the callback function as an argument to another function, we're only passing the function's reference as an argument, and the callback function is actually not executed immediately. It would be called back asynchronously somewhere inside the containing function's body. The containing function is responsible for executing the callback function when the time comes. Not only do callbacks allow you to control the order in which functions are run and what data is passed between them, they also allow you to pass data to different functions depending on your needs and cases. If you play around with the setTimeout or setInterval functions, you will notice that the callback function will be executed after the timeout delay without blocking other functions to execute during that delay. And this is because setTimeout is an asynchronous function. Now, let's talk about the most common use case for asynchronous behavior in JavaScript, HTTP requests. So first, what is an HTTP request? Sometimes you want to get data from somewhere else than from your code or files. You might need to get it from a database, for example, and to get it from there, you will have to access an API endpoint that will serve you that data. Say you're building a social app and you want to get the list of every post a user has made. You would then make an HTTP request to that external service, like an API, in order to retrieve that data so that you can display all the posts of that user on your social website. So let's think about what has to happen for a second. You first need to get the data. Then you need to parse the data, because all you want is maybe two keys out of the retrieved JSON, the title and the post, and its thumbnail, for example. Then finally, you need to render each of these extracted posts in your HTML. So you need to do action 1, then action 2, then action 3, without blocking the rest of the process. To make an HTTP request, you need to use the fetch function. In order to get data, the fetch function simply needs the URL from which to get the data from. But what is great about the fetch function is that it is made for asynchronous fetching of data. The return value of a fetch function is a promise object. A promise is a placeholder for a value that might not be known at the time of the creation of the object, meaning at the time the request is made. It allows you to provide callback equivalent or handlers with the asynchronous action's success or failure event. Instead of immediately returning the final value, the asynchronous method returns a promise object that expects a value at some point in the future. A promise can be either fulfilled, pending, or rejected. A promise is pending when it's still waiting for a response. It is fulfilled when it has received the response, and it is rejected when it could not receive the response. Promises have an amazing syntactic way of saying do action 1, then do action 2, then do action 3. You would simply chain it with a then method, which itself can be chained with as many then as you would want or need. It can result in quite readable code like the one you're seeing right now. You get the data, then you parse the data, then you inject that parsed data into my HTML. But what if something went wrong? Well, the promise object also has a method for that, which is called catch. Catch receives a callback to which an error object will be passed. So right now, just with these few lines of code, you could actually get to a full asynchronous post-fetching little system with even an error handling. That simple. So why use promise rather than the old-fashioned callbacks way we saw earlier? Well, with promises, you can, as we saw, chain multiple async operations together using multiple then method chaining, passing the result of one into the next one and into the next one again, and so on. This is much more difficult to achieve the same thing with callbacks, which will end up with what is known as the callback hell, a pyramid of imbricated callback functions, which you can, for example, see here. Promise callbacks are also always called in the strict order they are placed in the event queue, and error handling is much better as all errors are handled by a single catch method located at the end of the block, rather than being individually handled at each level of the pyramid. Promises also avoid inversion of control, unlike the callbacks that we just mentioned, which lose full control of how the function will be executed when passing a callback to any other third-party library, for example. Let me also mention the alternative syntax to handling promises, which is async and await. Async is a keyword that can be attached to a function, allowing the use of the await keyword within its scope. The async and await keywords enabled asynchronous promise-based behavior to be written in what some say would be a cleaner or more elegant style, but mostly avoiding the need to explicitly configure promise chains. Await expressions make promise returning function behave as though they are synchronous by suspending execution until the return promise is fulfilled or rejected. Use of async and await enables the use of ordinary try-catch blocks around asynchronous code. Async operations like promise are put into the event queue, which runs after the main thread has finished processing, so that they do not block subsequent JavaScript code from running. The queued operation will complete as soon as possible, then return their results to the JavaScript environment. In its most basic form, JavaScript is a synchronous blocking threaded language in which only one operation can be in progress at a time, as I mentioned earlier. But thanks to the evolution of JavaScript runtimes and web browsers, we're now provided with functions and APIs that allow us to register functions that should not be executed synchronously and should instead be invoked asynchronously when some kind of event occurs, whether it would be time passing, the user's interaction with a DOM element like a button, or the reception of data from an external source. This means that you can let your code do several things at the same time without stopping or blocking your main thread. Whether we want to run synchronously or asynchronously will depend on what we're trying to do. There are times when you absolutely want things to happen as soon as possible. For example, if the data an element needs to be rendered is already located within your code, like an array. But if we're running an operation that takes time, like as we mentioned with our post fetching, and it is needed for some rendering, it is better to extract this off the stack and complete the task asynchronously. It's very cool to play around with async behavior in JavaScript, and it can almost become like a habit of using promises or the async keyword. But you got to be careful that you do not overuse it, and make sure you apply these methods and keywords when there is an absolute need for them. Too often will I see the overuse of the async await keywords or promise that didn't need to be there because the retrieved data was local, or there was no relation between line 54 and line 55, and they could have been parallel. So as a final point, I would like to invite you to document yourself through the MDN on asynchronous JavaScript. It is full of resources, examples in practice, and has all the keys to understand these concepts much more broadly. I also would recommend looking into what the event loop is in JavaScript and how it has to do with allowing the asynchronous behavior. Uh, and as much as looking again any other JSConf on the topic, which you will find online on YouTube, which are really rich, especially the one on event loop that you can find online. I think that leaves us a bit too much time actually on Q&A. So please, if you have any question, feel free to ask me and I will try to answer them.
Okay, thanks. Yeah, so currently we have, so let me check our questions. But yeah, Japanese people, Japanese people are very shy. Yeah, I
Yeah,
don't
yeah,
think
I know.
they couldn't raise some questions. Hmm. Okay.
Was also a very, very interesting exercise. It was 5 minutes shorter than expected
Oh, yeah, yeah, it's
because
fine.
you're
Yeah,
presenting.
yeah, that's fine. That's okay. And so So yeah, I'd like to ask a question about these types of topics. So because
Of course.
so yeah, yeah. Previously, so Node.js had only callback style, but currently, so
Yeah.
they changed the style to the promise and async
Promises.
await.
Yeah.
Yeah, promises
Yeah.
and async await. So and but the Node.js also had one another streaming asynchronous style. So they have an stream, right? So and
Hmm.
yeah, and so browser also has these types of styles. Yeah,
Yes.
yeah. So how do you feel about these types of styles, like an streaming style? So that has a very yeah. These styles are very advanced one, right? So and
Yeah.
yeah, I think yeah. And so
So I think again, so it depends on what the context of what you're doing needs, right?
mm,
In
yeah,
most of the development case, the only time where we're gonna encounter those, at least as far as I could see, in most of the work, the only times where we're gonna encounter the old-fashioned styles is going to be when we basically work on Node.js itself,
yeah,
rather than
yeah,
actually performing tasks with Node.js.
yeah.
So I think right now, in a good 95% of the case, you're going to deal with promises because this is what you use to build most of the development that you would do with Node.js, right?
Yeah, exactly right. Yeah. So, but yeah, currently Node.js is trying to implement web streaming, the what
Mhm.
WG stream. So, do you know that? So, have you ever?
Sorry, can you repeat?
Yeah, yeah. Node.js would like to implement web stream. Web stream API is an that is new one. So
Yes,
yeah,
I think I saw it before. Yeah,
yeah, yeah, yeah. So maybe
haven't
in the future, yeah,
haven't digged in it. I know that I think it was there. Sorry, I think it was there. I mean, conceptually for a while, a couple of
yeah,
years, but I think they're trying to have this readable web stream, uh, how to say,
yeah,
concept pushed ahead, right? But
yeah,
just
exactly like
like
that.
promises, I think it's going to take time before we get to
Ah,
something like
okay, I
this,
got it.
right?
Yeah, 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 I got it. Yeah.
If you think
So
about it, async await is still not even available globally.
yeah, I agree with that. Yeah, and so I think Await has lots of use cases, like, and so they can
Mhm.
use very lots of use cases, and yeah, and
Yeah.
so if they'd like to get some data from URL, then so they can use in fetch and other
Yeah, exactly.
APIs. Yeah, these APIs are very useful, and yeah, so these use cases are a lot. Yeah, but the
Yeah,
web scraping use case is a few currently, but in the future, so maybe file uploading or downloading. So these types of use cases exist in the future. So they will use in web streaming services in
absolutely,
more.
sure. And I'm
Yeah,
really looking forward to these things because, you
yeah,
know,
yeah, yeah.
Node.js is very interesting in the way that it can live both in the past and in the future at the same time. Where
Mm,
exactly the case of async and await, they tell you it's the future of how syntactically you should deal with promises, but you still
yeah,
cannot use it in a lot of
mm,
places, right? So
yeah, 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 yeah. I agree with that.
hopefully evolution can accelerate a bit more on these things. I think we
Yeah.
need maybe Node.js community would benefit from a more global vision on adoption of standards. Um,
Mm,
there's a lot of scattered standards now due to all those different version almost of JavaScript that you can have with Babel or other transpilers. And I think really unifying JavaScript standards, because
mm,
ECMAScript is kind of ECMAScript is a unified standard that does
yeah.
not get enforced, right? So somebody can develop something with ES6 standards and somebody else with ES7, um, and you would find a lot
Absolutely
of
right.
compatibility issues there, right?
Yeah, 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 yeah. I think so. And so yeah, currently we have some standardized groups, right? And TC39 is also a group of the
Mhm.
standardization, and so what WG is also the specified standardized group. And
Yeah,
of course, in the JS ecosystem is also these types of groups. So we need to
yeah,
unify these types of
exactly,
groups. Yeah. So to
exactly.
use an API more friendly. Yeah. Yeah.
Exactly. And I think, already Node.js evolution is insane. The past decade and how Node.js has become really like the only acceptable standard for so many different things. Uh,
Mm.
I think we would benefit really from a better stability in terms of standards. Because right
Yeah.
now, even the most advanced developer will come across issues with, oh, okay, so this is an ES7 project, but where I have to deploy it, I can only have access to ES6, whatever
Mm.
transpiler. So these kind of things can be really cumbersome right now.
Yeah. 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 Mm. Okay, I got it. Yeah, thank you for this presentation and talk, and so thank you for answering my questions. Yeah, so much. And
Sure. Thank you
yeah,
very much for having me.
thank you very much. Yeah. Okay, so let's move on to the next topic. Okay, thank you so much
All
for
right.
Julian. Yeah,
Thank you very much.
yeah. Bye. Thank you.
Thank you. Bye.